Okay, so we learned in the last lesson about law of sines, but I only gave you the kind where you were given two angles and one side. Today, we're going to do another type, which is called the ambiguous case. And that is when you're given two sides and an angle, but not a sassy one, right? Not the side angle side, but when you're given instead side angle. What ends up happening, and if you read this backwards, it says a bad word, right? So you can think of this one as the pain in your butt case. Yeah. Okay. So do you remember back in geometry when you were doing your two-column proofs and you were never allowed to use a side angle as proof of something, right? You couldn't go, oh yeah, they gave me this, and so I can conclude blah blah blah. You couldn't ever do it. And this is the reason why, because when you're given two sides and the angle that's not in between the two sides, but instead one of the other sides, in fact, this angle will match one of these sides is the corresponding angle with that, or is the corresponding side to that angle there. And when you are given that, what it turns out is you could have three possibilities. You could have just one triangle that fits this information. You could have two triangles that fit the information, or there could be no triangle that fits that given information. Okay, so it's the pain in your butt one. You've got to check. So let's do an example. In triangle X, Y, Z, I'm going to say side X is 4, side Y is 5, and the measure of angle X is 27 degrees. So how do I know that this is the ambiguous case type? Do you notice that one of the sides they gave me is the same letter as the angle they gave me? That's how you know it's ambiguous case. That's how you know it's the pain in your butt one, and you've got to be aware. You got to go, oh, wait, this could be one triangle, two triangles, or no triangles. So you've got to check. All right, so we're going to find just the possible values of side Z. So I always start off by drawing a triangle. It helps me visualize it. X, Y, Z. Does it matter which way you label your triangle? No, as long as you realize that if this is angle X, side X is opposite that side. And if this is angle Y, then side Y is opposite that angle. So that's the part that you got to make sure that you label them correctly that way. But if you had wanted to put angle X up top and then Y, and that doesn't matter, right? Okay. So I've got side X is 4, side Y is 5, and then the angle X is 27 degrees. So do you see as you go around the triangle, what did they give me? Side, angle. Side, angle. Yeah. All right. So what can we do? Well, this is side Z, right? And I can't find it yet because they didn't give me angle Z, right? But what I can do is I've got angle X. I can find angle Y first. So that's what I'm going to do. I'm going to use law of sines. And I'm going to find angle Y first. So that would be sine of angle Y over side Y, so over 5, is equal to sine of angle X, but they gave me that angle X was 27 degrees, divided by side X, which is 4. And then you would multiply both sides by 5. Sine of angle Y is equal to 5 times sine of 27 degrees over 4. I just multiplied both sides by 5. And then to solve for angle Y, you need to take the inverse sine of both sides so that the measure of angle Y will equal inverse sine of 5 times sine of 27 degrees over 4. And your calculator is going to give you an answer for that. Put it in our calculator, make sure you're in degree mode, and what I got? Inverse sine of 5 times sine of 27 degrees, end that parenthesis, and then divide it by 4. And I get that angle Y is about 34 point, I'm going to go to 2 decimal places. So since it says 575, I'll say that it's 58 degrees. Okay, now here's the deal. Now that I've got angle X and angle Y, I can find angle Z, right? And then I can find side Z. But here's the deal with when you are given the pain in the butt angle, side angle triangle, you got the pain in the butt one, you could have 2 triangles. Yes? And so, how do you find it? Well, the other time that your sine is equal to, sine of the angle is equal to this, is when it's the supplement of it, 180 minus that guy. 180 minus 34.58 degrees. And that'll give you 145.42. So if there are 2 triangles that work, then these are the 2 angles for angle Y. Not sure if we will or not, but I'm going to show you how to figure that out. We definitely don't, this is definitely not a no triangle possibility. I'm going to give you an example where that happens too. But it would have shown up right here. But the fact that we got an answer for angle Y, we got 1. Okay, so there's definitely at least 1 triangle, and there might be 2. And if there is 2 triangles that work with this given information, then those are the 2 angles for angle Y. So I'm going to draw 2 different triangles to show you how this works, right? The original one, where they gave me, here's X, Y, Z, they gave me 27 degrees, 4 and 5 here, right? And the angle I just found for angle Y would have been 34.58 degrees. So there's 1 triangle. Or if there's 2, then the second one, and I don't draw it proportional, I just fill in, I don't worry about it, right? If you start taking time to draw a true obtuse angle for angle Y, it'll take you forever. So I just do same shape, right? But now the second triangle, if there is one, would be 145.42 degrees for angle Y. All right. So how do we know if both of them work? Well, you go to find angle Z. And in this case, the measure of angle Z would be 180 degrees minus 27 for angle X and minus 34.58 for angle Y. And you'll end up with 118.42 degrees. Oh, that looks messy. 118. I did not make it any better. Well, pooper scooper. Come on now. Let's try this again. 1, 8. It doesn't like my 8. Whatever. I'm not trying it again. That's an 18. 118. Bummer. All right. We'll get through this. Maybe. Okay. Okay. Or if there is a second triangle, this guy's angle for Z would be 180 minus the 27 and minus 145.42. And how you know if there's 2 triangles is if you get an actual positive value for angle Z here, then you've got 2 triangles that work. And when you do this, you will get 7.58 degrees, which is a positive value. So this is true. We've got two triangles that work for the given information, which is why you weren't ever able to use side-side angle as a reasoning in your two-column proof in geometry, because which one is it? Well, with the information they gave me, there's two different triangles that work for this. All right, so we've got two triangles. This is the case of the two triangles. And now the whole point, they wanted us to find side Z. Well, now I can find it. I have to find two of them. I have to find side Z on this guy and on this guy here. So now we'll find side Z using law of sines. I'm looking for side Z, so I'm going to put I'm not going to do sine of the angle over the side. I'm going to do the side over the sine of the angle. It just saves you a step. So side Z is the one I'm trying to find. It'll be over sine of, in this triangle, angle Z was 118.42 degrees. And then set that equal to, and I'm going to use the information they gave me. Side X was 4 over sine of angle X, which was 27 degrees. Use the information they gave you, because when we solved for angle Y, we approximated here. So it'll be a little, you could be off if you use your approximated angles. But we'll just use whenever you can, you should use the information they gave you, the exact values. Right? Okay, so solving for this, that means Z will equal, I need to multiply both sides by sine of 118.42. So 4 times sine of 118.42 degrees divided by sine of 27 degrees. And you will get approximately 7.75 when you get that. Do the same thing for this triangle. It'll have a different angle value, right? Remember that sides opposite their angles, like if here 145 degrees is definitely going to be the largest angle, well, that means 5 should be the largest side. Over here, it turned out that angle Z was the largest angle, and so your side Z should be the largest side. And it totally matches up too. Okay, but for this guy, we would have Z over sine of, this time my angle Z would be 7.58. And set it equal to side X was 4 and angle X was 27 degrees. Multiplying both sides by the sine of 7.58 degrees, you'll get Z is equal to 4 times sine of 7.58 degrees over sine of 27 degrees. And that will end up giving you a 1.16. So you have two answers. Z is either 7.75 or 1.16. Because two triangles satisfied that given information. Pain in your butt, right? Yes, I know. Side angle. Tells you right there it's going to be a pain in the butt, right? SSA. Okay, let's do another example. Let's do. Make sure I'm on the page here. Example 2 is in triangle XYZ. Let's let side X be 6, side Y be 5, and the measure of angle X is 27 degrees. And same directions, we're going to find the possible values of side Z. Okay, so I'm going to draw the triangle again. X, Y, Z, those are my angles. Side X is 6. side y is 5, and then the measure of angle x is still 27 degrees. All right, so you start off using law of sines to find angle y. Oh, notice side, angle, right? Pain in your butt. All right, so to find angle y, you're going to do sine of angle y over 5 was the side for y, and then equals sine of angle x over side x. Multiplying both sides by 5, you'll get sine of y is equal to 5 times sine of 27 degrees divided by 6. And then the measure for angle y is when you take the inverse sine of both sides, it isolates this y. And so you'll do inverse sine of 5 times sine of 27 degrees all over 6. Put that in our calculator. Inverse sine 5 sine 27. Make sure you end the parenthesis after you're entering in that angle for sine, and then divide by 6. And I'll get 22.23 degrees. All right, so I know I for sure have one triangle. Let's see if we have two. All right, so, or the measure of angle y would be 180 minus the 22.23. And that'll end up giving you 157.77 degrees. All right, so those are the two possibilities, if we've got two. Let's find out if there will be. All right, so I'm going to draw the two triangles, just because I find it helpful to visualize it. I've got 27 degrees, I've got x is 6, I've got y is 5, and I need to find z, or second triangle, x, y, z, 27, 6, 5. Okay, and then the first y value we came up with was 22.23 degrees. And the second triangle, if it exists, is 157.77 degrees for angle y. All right, so we can find angle z right away by doing the measure for angle z. The three angles in a triangle add up to 180. So 180 minus 27 minus 22.23. And you'll get 130.77 degrees. Or over here, the measure for angle z on this triangle would be 180 minus 27 and minus 157.77 degrees. All right, so what happens? What do you get? You end up getting 180 minus 27 minus 157.77. Show you on my calculator. What? Negative 4.77 degrees? Doesn't make sense when we're talking about an angle. So, what does that mean for us? That means, nope, there is not a second triangle. There's no way that you can have a second triangle and have this angle z be a negative angle. Not going to happen. So this second triangle is not possible. And what that means for us is there's only one answer. Only one triangle works for this information. Only one triangle. Right? And so we've got the measure of angle z. And so now we can find side z. by doing z over sine of angle z that actually worked, 130.77 degrees, and set that equal to x was 6 over sine of 27 degrees. And so your z will equal, multiplying both sides by the sine of 130, you'll have 6 times sine of 130.77 degrees divided by sine of 27 degrees. And you end up where z is about 10.01. Only one value that works for that given information. Okay, one more example. And that is in triangle XYZ, side x is 2, side y is 5, and the measure of angle x is 27 degrees. Let's find the possible values of side z. So let's draw triangle x, y, z. X is 2, y is 5, angle x is 27 degrees. So I'll start off finding angle y again. It's the only one you can find because you only have side y, you don't have side z. So, well, side z is what they want you to find, but you don't have angle z or anything. So side, angle, pain in your butt. So you're aware you're looking for, there could be 1, 2, or 0 triangles. And so I'm going to do sine of angle y over side y is equal to sine of angle x is 27 degrees over side x is 2. And then multiplying both sides by 5. 5 times sine of 27 degrees divided by 2. And then angle y, you're going to take the inverse sine of both sides so that you isolate this y by taking inverse sine of the right-hand side. It's the measure of the angle. All right, so let's put this in our calculator to see what happens. Inverse sine of 5 times sine of 27 in that parenthesis divided by 2. What? Domain error? What the? Domain error. All right, well, if you get a domain error, I would double check that you put it in your calculator correctly first. But why? Why was there a domain error? Do you remember that sine of any angle has to be between 1 and -1? So let's figure out, you're taking inverse, you're saying sine of some angle, sine of angle y is equal to this 5 times sine, 5 times sine, come on, we can do this, 5 times sine of 27 degrees divided by 2 is about 1.134. So this guy turned out to be about 1.13, right? And so, and there's no way sine of an angle is never bigger than 1. So that's why you're getting the domain error. And when you get a domain error, what is your answer? No triangle exists. There is no triangle that satisfies the given information. It's not going to happen. So, all right, there we go. I hope you all have a fabulous day. Come see me in office hours. Bye.